तो आज हम करने वाले हैं डेंसिटी ऑफ क्रिस्टल, डेंसिटी ऑफ द सॉलिड, और डेंसिटी ऑफ सॉलिड इज सेम एज दैट ऑफ डेंसिटी ऑफ द unit cell, because when unit cell is arranged in 3D, then ultimately we get the whole crystal. Okay, so whatever be the density of a unit cell, that is same as the density of the crystal, because same unit cell is extended in 3D to make a whole crystal. So let's calculate density of unit cell. Means to calculate density of a solid, we have to calculate density of unit cell. Now what is density of unit cell? So density of unit cell is, density means mass over volume. So density of a unit cell is mass of unit cell divided by volume of unit cell. That's it. Density of a unit cell is equal to mass of unit cell divided by volume of unit cell. Now, if Z is number of spheres, means constituent particles. Spheres, what it means? Spheres means constituent particles, atoms, ions, molecules. So Z is number of spheres per unit cell. Okay, and if M is mass of each sphere, then mass of unit cell is Z into small m. And if A is edge length of cubic unit cell, I'm talking about only cubic unit cell, then what is the volume? That is A cube. So if we denote density by small d, d is density of unit cell, then dA is equal to Z into small m divided by A cube. So this is the relation. But now mass of each sphere, to calculate mass of each sphere, let us say capital M is the molar mass of particle, means sphere, and Na Avogadro's number. So to calculate mass of a sphere, capital M is divided by Avogadro's number, because in molar mass, as the name suggests, molar mass, it is the mass of 1 mole of the spheres. So mass of one sphere is molar mass divided by Avogadro's number, because in 1 mole there are Avogadro's number of particles, right? So in this way, now D, as we write Z into small m over A cube, now it becomes Z into capital M over A cube into Na. So this is the relation for density. Now moving further, if A is in centimeter, and capital M is gram per mole, what is the unit of capital M? It is in gram per mole. and Na is per mole. So that means what are the unit of density? Density is in gram per centimeter cube, and this is the relation. But if A is in picometer, so if A is in picometer, and a picometer, or we can say 1 picometer, 1 picometer is 10 raised per minus 12 meter, or 10 raised per minus 10 centimeter. Okay, so in this way density is equal to Z into M upon AQ into Na multiplied by 10 raised to power 30, right? Because now we can write A cube as A into 10 raised to power minus 10 centimeter. So this is in gram per centimeter cube. Then it should be multiplied by 10 raised power 30. Keep in mind, there are the two relations. First is Z into capital M over A cube into Na. This relation is used when A is in centimeter. And this relation, when Z into M upon A cube into Na into 10 raised power 30, this is used when A is in picometer. Right? Yes, beta. Any doubt in it? Pranam, beta. Yes, beta. Tell me. Have you any doubt? So let's do some numerical on it. But I will take numerical from NCRT or JEE. Wait. Oh my God. Okay. So here we have a question from 2020, JEE 2020. Okay, so this is the question. This question came in September 05, 2020. Okay, so let's do this question. A diatomic molecule X2 सॉलिड स्टेट के टाइप्स कौन कौन से होते हैं? But I didn't understand. Types means a diatomic molecule X2 has a BCC center body centered cubic structure. Edge length is 300 picometer. So see, as it is BCC, tell me what is Z? This is BCC. So tell me what is the value of Z? Yes, beta. What is the value of Z? What is the value of Z? Tell me fast. And then edge length is 300 picometer. See, edge length is given in picometer and density of the unit cell is given in gram per centimeter cube. So we have to calculate number of molecules present in 200 gram of X2. Avogadro's number is given. Avogadro's constant is given 6 into 10 raised power 23 per mole. Yes, first tell me what is the value of Z for BCC. First, what is the value of Z for BCC? I know there is a time lag, but you can answer it now. So say for simple cubic, Z is 1. For BCC, Z is 2. And for FCC, Z is 4. So in this way, here as it is BCC, so Z is 2. Now, relation is D equal to Z into capital M upon A cube into Na multiplied by 10 raised to power 30. Right? Here A is in picometer. That's why I write it 10 per 30. Okay. So better to take these as such because it is in Na only. So M upon Na is equal to D into A cube divided by Z into 10 raised to power D into A cube divided by Z into 10 raised to power 30. Right? Now what is D? Value of D is 6.17. And what is the value of A? A is 300. 300 raised to power 3 divided by Z, that is 2 into 10 raised to power 30. Okay. This M upon Na is mass of one atom, right? One molecule of X2. Okay, so going further, 6.17 into 27 into 10 raised to power 6. divided by 2 into 10 raised power 30. Just solve it fast. Yes, beta. And 2. Yes, beta. Okay. It is 2, beta. Z is 2. Okay. So it comes out to be 27. I will multiply it because calculator is allowed during the exam. 6.17 into 27. So it is 166.59 and divided by 2. So it is 83.295 into 10 raised to power 6 minus 30. So it is minus 23. So better to go like this. M equal to 83.295 into 10 raised power minus 23 into Avogadro's number, and Avogadro's number is given 6 into 10 raised power 23. So this is cancelled. So 83.295 into 6. So it is round about 500. 6 and 30. So it is, oh, it is minus 24. Sorry. It is minus 24. So it comes out to be 10 is minus 1. That means the value of molar mass, it is 500 into 10 raised power minus 1. That means it is 50 gram per mole. So molar mass comes out to be 50 gram per mole. And what is the total mass? It is 200. So number of moles of X2 equal to weight, or we can say mass over total weight over molecular weight. So weight of X2 is given to you, that is 200, and molar mass is 50. So it comes out to be 4. So number of molecules of X2, moles are 4. So molecules are 4 into Avogadro's number. So that means C is the right option. Yes, beta. Got it? Any doubt in this question? Next question. again from 2020. So this is the question. Yes, beta. Can you solve it? Are you able to solve it? Calculator is allowed. Okay. You can use calculator. So can you solve it? I will start solving it and you will solve it simultaneously. Okay. An element with molar mass 2.7 into 10 raised to minus 2 kilogram per mole. Molar mass is 2.7 into 10 raised to power minus 2 kilogram per mole. It forms cubic unit cell with edge length. Edge length is given. That is 405 picometer. If its density is 2.7 into 10 raised to power 3 kilogram per meter cube, then we have to calculate a radius of the element in terms of number into 10 raised to minus 12 meter, means in picometers. Okay, so before calculating R we have to calculate A, because when we write density it is Z into M upon AQ into Na into 10 raised per 30, right? A is given to us, edge length is given, but the relation between R and A, that is only possible if we know the type of the unit cell. Is it simple cubic, body centered cubic, or face centered cubic? And to find that we have to calculate Z. Sorry, A is given to us. Okay, but what is the relation between R and A? That is only possible after finding out the type of the unit cell, and type of unit cell depends upon Z. Z is number of spheres per unit cell. If Z comes out to be 1, then it is simple cubic. If it comes out to be 2, then it is BCC, and if it comes out to be 4, then it is FCC, right? Got it, beta? Thank you, Sebao Mini. So now let's go further. Z is equal to D into A cube into Na divided by, yes, divided by M into 10 raised to power 30, right? Okay, so density is given to you, but no, density, yes, density is given, but it is in kilogram per meter cube. Density is in kilogram per meter cube, and for this relation density should be in Yes, beta. Density should be in gram per centimeter cube. So first we convert density into gram per centimeter cube and molar mass into gram per mole. Okay. Yes. So first capital M. Capital M is 2.7 to 10 raised power minus 2 multiplied by 10 raised to power 3 gram, right? So that means it comes out to be 2.7 into 10 gram per mole. That means 27 gram per mole. So capital M you should write as 27 gram per mole, right? 27 gram per mole. Okay. Yes, beta. Now molar mass we have calculated. Now calculate the density or convert density into gram per centimeter cube. Okay, so I will do it on the next page. Density. Density is given, that is 2.7 into 10 raised per 3 kilogram per meter cube. Okay, so it is 2.7 into 10 raised per 3 into 10 per 3 gram, 10 raised per 2 centimeter raised to power minus 3. So it is 2.7 into 10 raised per 6 gram into 10 raised to power minus 6 per centimeter cube. That means 10 per 6, 10 per minus 6 cancel. So it comes out to be 2.7 gram per centimeter cube. See what we have done. We convert them in the units, that is should be in the formula. See, D is density is in gram per centimeter cube. So we convert into gram per centimeter cube. A should be in picometer. So it is already given in picometer. Molar mass should be in gram per mole. So we convert it into gram per mole. Now we put these values in the formula. Okay. So now Z equal to D. What is the value of D? D is 2.7. Then A cube. A is 405. A should be in picometer. Okay. Then picometer. Then Na. Na is 6 10 per 23. Avogadro's number is not given, but we write it in integer form. So it is 6 into 10 per 23, and then capital M. It should be 27 into 10 per 30. So these are the values. Now just use the calculator, because nowadays calculator is allowed. So 2.7 into 405, how many times? 3 times, and then into 6. Okay, so it comes out to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Means it is 10.8, or you can write it as 108. 8 into 10 raised to power 108. 1, 2, 3, 4, 5, 6, 7 into 10 power 7 into 10 raised power 23 divided by 27 into 10 raised power 30. So 7 plus 23, obviously 30. So they are cancelled, and 108 divided by 27. So it comes out to be, yes, 108 divided by 27. So it comes out to be 4. So that means unit cell is FCC. So it is FCC unit cell, or we can say CCP, FCC or CCP. And for FCC or CCP, what is the relation between R and A? For FCC, R equal to A by 2 root 2. R equal to A divided by 2 root 2. So R is equal to A is 405 divided by 2 into root 2. So it is 414. So it comes out to be 405 divided by 2 divided by 1.414. So it is 143.2 picometer. So this is the value. So that means 143 picometer. So it is 143.2 into 10 raised per minus 12 meter. So that means the value in this case, here it should be 143.2. So nearest integer means it is 143. So it should be 143. Yes, beta. Any doubt? Done, beta? Next question from 2019. Try to solve it. Okay, so this is the question. The question is, at 100 degrees Celsius, copper has FCC unit cell and unit cell structure with cell edge length x angstrom. Means A is given. First it is FCC, so Z is for FCC, and edge length is x angstrom. So better to convert it into centimeter. So it is 10 raised per minus 8 centimeter. So what is the approximate density of copper in gram per centimeter cube? Atomic mass is given. Now your relation is density is Z into capital M upon A cube into Na, right? So Z is 4 as it is FCC unit cell, and edge length, molar mass, it is given 63.55. They say it is given in U. So U is same as gram per mole. Okay, U is for one atom atomic mass, and to find out its molar mass, atomic mass of copper is 63.55 U, unified mass. Okay, and if we write it as molar mass of copper, so its unit becomes gram per mole, and value remains same, 63.55. Okay, so divided by A cube. So A is x into 10 raised per minus 8 cube, because if we use this formula, A should be in centimeter. That you should keep in mind. Density in gram per centimeter cube, capital M in gram per mole, capital M 63.55 gram per mole. Okay, and it is given U, but I told you just now that U is for one atom, and for 1 mole it becomes gram per mole. Value remains same. Atomic mass expressed in U